We looked at stretching graphs vertically and horizontally in our last lesson. Today we're going to go ahead and take a look at what happens when we are shifting graphs sideways and up and down. Let's go ahead and take a look at this one here. If we graph this, once again going and using our trig zoom, so go zoom down to 7. You may have left it there, you may have not. Now you'll notice your original one goes to the origin, but you'll notice this one here goes and crosses a little bit to the right of it. Now this is 0. This first tick mark is 90 degrees. It's crossing halfway in between, so it looks like it shifted your graph 45 units to the right, and that's exactly what it's doing. Let's go ahead then and take a look at our plus 90. Graphing our sine of x plus 90. Here's our original graph. Okay, original graph right here. Now it's shifted all the way over here to that first tick mark, which we know was 90 degrees difference, but since it's going negative, it's negative 90. So in other words, it shifted our graph 90 units to the left. So if you're adding or subtracting something to the x before you apply the sign, you're shifting it left and right. If it's a minus 45, you shift to the right. If it's plus something, it's shifted to the left. But what happens if you add or subtract after you do the sign? So let's look at sine of x plus 2. Here's your original. Oh, it crossed here at 0, height of 0. Now it's crossing up here at a height of 2. In other words, it just moved it 2 units up. So you might suspect this one here then would move it 2 units down, but let's check. So sine of x minus 1. Here's your original graph. And yes, it did shift it 1 unit down. So if you're adding or subtracting something after the x, after your sign is complete, then it shifts it up and down. So once again, the number in front affects your amplitude. That's your vertical stretch, and we looked at that in the last lesson. Multiplying your x by a number does a horizontal stretch, and your period then becomes 360 over b, or if you're dealing with radians, it'd be 2 pi over b. If you added or subtract something after the x, it shifts it horizontally. That's referred to as a phase shift. If you are subtracting something, it shifts it to the right. If you are adding something to your x, it shifts it to the left. Now, if you're adding something after you've completed the sine function, that shifts it up and down, a vertical translation or a vertical shift. Also, this d value here tells you the equation of your midline. The midline, once again, is that horizontal line that would cut your graph in half. And here it would be at a height of -1, and that's what we had right here for our d value. So let's go ahead and take a look at graphing some of this stuff. So let's start out finding our amplitude. Remember, your amplitude's always the number in front. Then b, in this case, is -4. That affects your period. Remember, your period is always 360 over the absolute value of that b value. So it's really 360 over a +4, which ends up being 90 degrees. Now we're wondering, are we shifted up? Yes, because we're added to this. So we know we're going to be 2 units up. And since we are adding here to our input before we do our sign, it's going to shift it to the left that many degrees of 90 degrees. Now, remember, the equation of your midline is always this one right here. So we're going to go ahead and sorry about that, and graph this. What I always like to do is just start out with my basic graph to begin with. We're dealing with a sine. Remember, sine starts at the origin. Oops, sorry about that. Comes down and goes back up, and I think I'm going to redo this. This is a very rough graph. It's kind of hard to do it without being at the board itself, and I'm not at the board right now. But we're going to now go ahead and put our tick marks in. I'm going to mark this as a positive 3 because we're 3 high because we know that that's our amplitude. So I'm going to mark this as a negative 3. Now I'm going to mark this right here as one complete period. We know one complete period is 90 degrees. So therefore halfway in between is 45. And by the way, this is supposed to be a nice smooth curve. It's not supposed to have the irregularities, but hopefully you know that. Now, keep in mind that this is repeated going on to the right and to the left, so I can continue that graph on. What I'm going to do next is my phase shift to the left. I need to take this whole graph right here and move everything 90 units to the left. So I need to take this point right here, which is at a height of 0, move it 90 units to the left. Well, that puts it here. I need to take this one here that's at positive 45, move it 90 units to the left, so that puts it over here at negative 45. I need to take this point here that's at a height of 1, move it 90 units to the left, and that puts it over here. Now, you'll realize that when we're moving this one here 90 units to the left, we're getting the identical shape of our graph over here. Now, most of the time that's not going to be the case. It just happens to be that way with this one here. So, I'm going to go ahead and try to show you what happens here. And I'm going to change my color. We're going to take this graph and just slide it over here 90 units. In other words, when we do that, it ends up being right on top of itself. Most of the time you won't be. Now we need to go ahead and move it 2 units straight up. So let's go ahead and do that. So we have now this graph here in dark blue that I need to move 2 units up. Here we're at a height of 3. I need to move it up to a height of 5 now. So I just go straight up. And now we're at a height of 5. Now, I like to draw my graphs in stages. So your only true graph, your actual graph of what's going on here, is really just the dark blue. So when you're doing this, you may want to use different colored pencils, or you may want to make these dotted lines until you get to your final one, which is your final one. But it's going to basically be just this blue graph. Now down below here is an actual better graph of what's going on. A little bit nicer than what I could draw by hand. So let's go ahead and find our amplitude here. Remember, amplitude's absolute value, what's in front, so we know that's going to be 4. Our b value is 1/2. So our period is going to be our 2 pi over 1/2. Instead of dividing by a fraction, you multiply by 2, so you get 4 pi. Now you might be wondering, why am I dealing with radians here instead of degrees like I was on the last one? Well, in the last one here, inside the parentheses, we had 90 degrees, so that's why I knew we wanted to be dealing with 90, or degrees. But here inside of our parentheses, we have radians, so I know I need to be dealing with radians. Now, this minus 3 out back here shifts it 3 units down. And this right here, since it's in the parentheses before I do the cosine, shifts it left and right. Since it's a minus, we're going to be shifting it 1/3 of a pi to the right. Now remember, the equation of your midline always comes from how far you're shifted up or down. So that is going to be a minus 3. So let's go ahead and draw our cosine graph. Remember, cosine starts at a height of 1 at your maximum and then goes down from there. Now for this one, since I have an amplitude of 4, I'm going to start it at a height of 4 and then go down to a depth of negative 4. And then I'll go ahead and add in my period after that. So here's my basic cosine graph, and keep in mind that this is going to continue on to the right and on to the left. What I want to do is I'm going to mark this at my amplitude of 4, mark this as my opposite of my amplitude of how far down we're going, so negative 4. Mark this, because that's one complete period. We know one complete period is 4 pi, so I know this is 4 pi here. So therefore this is 2 pi. Now, keep in mind that this graph right here goes on forever to the right and to the left, so I'm going to just continue to do that. So we have our basic graph going on to the right and to the left. Now we got to go ahead and do our shiftings. We need to move it down 3, and to the left a third of a pi. So you need to figure out what a third of a pi is. Well, this is 2 pi, so therefore this is going to be a pi here. So in other words, a third of a pi would have to be a third of this distance right here. So a third of a pi would have to be this distance right here. So that's how far we're going to move all of our points to the right. So I got to move all my key points. My key points all high. Key points are your max and mins and where you're crossing the axes. We got to move all those key points, this horizontal distance right here, to the right. So I'm going to go ahead and replot these that distance to the right. And continuing to plot these key points that distance to the right. And then all I have to do is just go ahead and take my graph and redraw it going through those blue points. So I'm going to take my original graph and just move it that far over so it goes through all my key points. Now I got to go ahead and move everything 3 units down. So I need to go ahead and mark those points. Take all my new key points and drop them 3 units down and draw a line or a curve going through those. Now that I have all my new key points, the ones that are directly below the blue ones, I need to draw my graph going through those. So now I'll go ahead and just drop it down 3 points. You guys won't be able to do that, but you'll be able to just sketch your graph going through those key points. And it should look about like this. Now down below here, and once again, your light blue and your purple are just used to be able to get you to your final one. So if you want to use dotted lines when you're doing that, that's fine. Down below here is a better looking image. So now let's go ahead and work backwards. We're given a graph. Now we want to work backwards and find our A, B, C, and D. Remember, A is what's in front of your squared term, B is what's in front of your x to the first power, C is the number that's added or subtracted after the x, and D is the number that's going here at the end. Well, A and B use similar formulas, but for A it's max minus min divided by 2. When we're talking about our max and min, we're talking about highest points and lowest points. So highest points and lowest points are referring to the y's. So our maximum is a height of 2, our minimum is a height of a negative 4, so we'll go 2 minus a negative 4, which is really a 2 plus 4, which is a 6 over 2, which is 3. That's our amplitude. D, once again, tells us the equation of our midline. That's using our max and our min, but we need to add those together. So our 2 plus our negative 4, which is a negative 2, divided by 2 gives us a negative 1. So the equation of your midline would be y equals a negative 1. I'll just go ahead and draw that in quickly. The green dotted line's there just to tell you the line that cuts your graph in half horizontally. Notice we go 3 above and 3 below that, and your amplitude's always how far above and below that horizontal midline that you go. So once again, A is 3, and our D was that minus 1. We now got to go ahead and find our period. What we do know is we know that our maximum is here, and our minimum is here, then we have a maximum. So between the two maximums, one full period. So in other words, this horizontal distance that we have from our maximum over to where your minimum is down below, that's only half your period. So if I go ahead and take my 465 and subtract my 195, that's only half of it. So I need to double that answer to get my full period. So my full period is 540. Your B value is always your normal period of 360 divided by your actual period of 540. You go ahead and simplify that down, you get your B value to be 2/3. We now need to go ahead and figure out C. C is how far you have to move your graph. Well, cosine normally has a maximum starting out here. So how far over here did we have to move it? Well, we had to move it from left and right 0 over to the right 195. So your C value then is 195. Since you're moving it to the right, that means it's a minus.